My name is Gordon Jennings, and I will be your guide throughout this video, NES Repair Secrets by Irata Systems, Mesa, Arizona. Through the course of this video, we will instruct you how to repair, how to troubleshoot, how to recognize symptoms for the NES system, the controller, the control deck, the main board, and some other commonly occurring problems on selling these videos. So what I ask from you is that you obey my copyright on this video and don't make any copies. If your friends or acquaintances would like a copy of the video, please refer them to Irata Systems, Mesa, Arizona. NES system reached a popularity in America that no other video game system has reached to this date. I began repairing video games clear back in the early 80s with the Atari. In the later 70s and the early 80s with the Ataris. Even Atari did not reach the popularity that the Nintendo Entertainment System has reached. There are probably 4 or 5 million of these in existence in the United States. Eventually, every single one of them will break. And I am here to show you how to repair those. I will take you step by step through the system, beginning with one thing I'd like you to notice. This is not a fancy video. It doesn't have a lot of graphics. I don't have a lot of subtitles. I don't have fade-ins. I don't have fade-outs. I'm doing this at my workbench here. It's very simple and straightforward. The purpose of this video is not to wow you with great graphics and great subtitles and fade-ins and great special effects. That's not the purpose of this video. The purpose of this video is to instruct you on how to repair this. So that's my main purpose, and we will do that through the course of this video. With the NES controller, part number 004 is pretty straightforward in repair. You'll note again that there are 8 functions: up, down, left, right, select, start, A and B. There are 2 cartridges that are good for testing the controller. The Legend of Zelda, good one, is Breakthrough. Breakthrough, you're able to test most of the functions except select, and you're able to do that on startup. So let's put it in and find out. We insert our cartridge and turn it on. You'll notice that we can now test the select button at the beginning of Breakthrough. If the select works, you can go ahead and select 1 or 2 players, either one, it doesn't matter, and hit start. Now we've tested these 2 functions. They test fine. Now we can test up, down, fire, A and B. A makes it jump, B makes it fire, left, right makes it accelerate, and left makes it slow down. So now we've been able to test all the functions in this controller, and they test out fine. The first thing to check for, if and when a controller doesn't work, is the cord. Look for physical damage. I look at the controller, turn it over, roll it around, look for any kind of physical damage that may have occurred to it, such as being dropped. I've seen some that have been chewed on by animals. I've seen others that have been literally run over by cars that have been broken in half. So check the controller for any damage. The next thing you want to do is check the cord for any punctures or tears in the cord, which is the most common problem. So what I usually do, turn the game off, pull the cord out, and I simply run my fingers along the outside of the cord, and if there's any kind of bump or cut, you'll be able to feel it. So I run my finger all the way along the cord and to see if I can feel any cut. If there is a cut, the cord is usually bad. Now there's 2 things you can do on that. You'll notice that this controller cord is actually shorter than the normal one. When I got this controller in, it had been bit or cut approximately 6 inches from the top of the cable. I was able to cut it off and shorten it, and thereby retaining the usage of the controller. However, it's just a little shorter cord now, which is usually not a problem for most people. If the problem occurs, or the bite occurs down in this end, it's usually a little more difficult to repair. And I will show you how to repair one of those. The first thing you want to do is clear out an area where you can work, and if the controller is bad and you find that the cord is in tip-top shape, again, like I said, the first thing you want to do is clear out an area. So I will remove the control deck from the surface of our workbench, and usually what I like to do is lay some kind of soft cloth down so that this doesn't get scratched. Now let me back up here and make one note. Please be aware of static electricity. I've chosen a workbench that is made out of wood, and I'm working on a cement floor where there's very little chance of static buildup. If you are in an area that is susceptible to static electricity, please get a static bracelet and ground yourself before working on any of these. Some of the chips that you'll be working on in the Nintendo are CMOS chips and are very sensitive to static. So be very careful with that and be aware of it. So the first thing I like to do is I usually like to cover the bench with something soft that won't scratch the controller should there be any kind of particles on there. The next thing you'll need is the small tipped Phillips screwdriver, and I want you to take out all 6 screws. Loosen all 6 screws. Don't pull them out yet. Loosen the 6 screws of the controller. Okay, we'll move that out. Now notice the cord comes in, it wraps around these two. I'm going to pause the camera here and zoom in so you can see a little better a close-up of this. Okay, you will note that the cord comes in, it wraps around these 2 strain relief pins, and these are corrugated, have edges on them to grip it so that this cord can't slide out, and it allows you to give a little pull or a little tension on this cord without pulling it out. So when you replace it, make sure that it wraps around and follows the diagram into the center here, through the center, and in where it's attached. Now notice the controller has one controlling chip in it, and that is a CD4021, which is a CMOS chip. And I want you to understand the purpose of this chip. What this chip does is a serial parallel chip, and when the controller dies, 99% of the time it's that chip. So all you have to do is remove the chip, and I'll show you how to do that in a minute, and replace it with a new chip, and usually the controller will work. But you need to ohm out the cord first of all to make sure that the cord is okay. So the next thing that you do is remove the cord by pulling it off of there, lay it back down, and pull the circuit board off. Now there are inside the controller there are 3 silicon membranes that reside in there that you can actually pull these out, set them aside. Sometimes dirt or food will get underneath them, so as I take them out I make sure they're clean. I just kind of rub them off. The best thing to do would be to get a Q-tip and rub them off with a Q-tip. So we pull those off, make sure that they're clean. I usually wipe them on the towel. Okay, and now there are some buttons inside. Now notice on the buttons that there are some latches here, some holes where the levers from the buttons fit in. There is a correct direction that the button will fit in, and if you try to reverse the button, it'll still fit in. But some controllers I've seen where one side of this is larger than the other, so you can't get it turned around. I think in this one it's interchangeable. But this also comes out, and it might be a good idea to pull that out and to clean that while you're in there, and to tip the button over. Now, all of this can be washed by just immersing it in warm soapy water, and you'll be able to clean it off. Before you put it together, again, make sure that it's clean and dry. Now, what I have here, so that you can see, is I have a clear bowl of warm water that I put just a little dishwashing soap in. I'll use that to clean these parts with. So what I usually do is immerse the parts in the warm water, and even the top, if it's unusually dirty, put that in there, and remove the screws from the bottom. Sometimes they're a little tricky to get them out. You have to kind of push hard. 6 screws. 2, 4, 6. Put that in there too, and let them start to soak. Okay. Now, if we flip the circuit board over, you'll notice that there are some contacts on the circuit board that are where you make contact. As you'll notice that this is the exact layout of the front panel. We have up, down, left, right, select, start, A, and B. Now, it's very easy for food to get down into these, so what I do is I just take a cotton swab and clean the top of these. Usually you'll see large chunks of food or dust, dirt, pet hair, something like that down inside. Okay? Now, check for any kind of break. Sometimes I get these in where they're cracked. Now, one thing that you want to do is make sure when you get the controller apart, make sure that all the wires are contacted properly. The way that you do that, unfortunately, you have to have a part for that. If you take apart a Nintendo, which I will show you later, you will have where the controller plugs into the main control deck. There's a little jack and wire assembly that goes on the end of this, and I've already got one here that I'm going to show you, but you may want to use one to troubleshoot controllers. Now, I will show you how to get one of these, to take one of these out a little later on, but for the sake of discussion right now, let me just show you how to work this. You insert that into the jack, and now the color here 99% of the time is the same color here. And I'm not sure what the camera angle is here. Using a voltmeter, you can check to see that the cord is correct. So I'm going to put this on. I have a voltmeter that has continuity check. That means that whenever there's a dead short between the two leads, this will give an audible beep. It's a nice feature to have on any meter. So you don't have to look up. So what you do is you take your meter and you touch it to the yellow, and the yellow on this end, and you should get an audible beep. Work your way down, making sure that you get a beep on each one of the wires. And lastly, we have white. White you usually have to flip over both sides to get to. Okay, so now we've checked out in this particular case, we've checked out the cable. We know that the cable is okay. If the cable were not okay, it's usually a result of, as I said earlier, a bite or a break or a tear in the cable. If you have two choices, you can replace the cable with another cable, usually off of a junk controller, or you can find a supplier of the 5-strand cable and replace the cable with the connector on either end, connector and controller on the end, or you have the choice of just shortening it and resoldering this end, which is usually the choice that I make. What I do is let's say that the cut were to occur here, right here, I would simply cut the wire before that, strip it back a couple of inches, as you see here, desolder this end right here, and pull it out and shorten the cable. And I'll do that for you in just a moment and show you how to do that. The other thing that you can do, if the cable all ohms out correctly and you get continuity through the cable, then chances are that it's the 4021 chip. It's a shift register, a serial parallel shift register. And usually that's what goes wrong. If the cable checks out properly, as we've just shown you, then the next thing to check is the chip. And the chips are so inexpensive. This one happens to be a Motorola chip, an MC14021. And you can get that from most supply houses. Pull these out now that they're rinsed off, and set them down and let them start to dry out for reassembly in just a moment. Okay. Now I'm going to take the water and put it back in the sink and get rid of it. Now if you've determined that the chip needs to be replaced or the cord needs to be shortened, what you'll need next is you'll need a soldering iron, and I like to have a clean sponge to keep the tip of it clean. You'll need a method of desoldering, either a solder vac, solder sucker, or solder wick, and then you'll need some solder to replace that, and you'll need the spare chip. So I'm going to give you a moment to go round those up. I'm going to go ahead and plug my soldering iron in so that it starts warming up. Okay, I'll let that warm up. I have a special soldering station that I place here so that the soldering iron doesn't fall down. So I'm going to pause the video and put in the soldering station and show you how to replace one of those chips and also shorten the wire. Okay, what I like to do is use a board, a special board here, that if I burn it, if I scratch it or something, it won't hurt. I can throw this away, and that way I don't mar my workbench. And then also I have this solder holder attached. Sometimes the cord gets caught on something as I draw my arm back, and this way it doesn't get pulled away. I also have a clean tip here. So I've now folded up my parts. I'm going to set the parts gently over here to the side and let them start drying. I'm going to take my 6 screws. And put them over here so that they don't get lost. And now I'm going to hang this up and let it start to dry. Now, as I mentioned earlier, in addition to a hot soldering iron and a clean tip, you'll need some solder. So I usually take some solder and I just roll off a chunk of it so I don't have to mess with that large spool. I get my solder lead out to where I can solder. I have some solder wick that I've purchased from a supply house. I like to keep it clean so that I have a clean tip off. Wire strippers and wire cutters is what you'll need. Now, on the CD4021, I've ordered quite a lot of them. I have quite a lot in supply. You may want to do the same. So, you'll also need a spare one of those if you're going to replace that. Okay? I'm going to take the camera and zoom in closer so you can actually see what's going on. So I'm going to pause it here. Okay, kind of close quarters here, but that's fine. Lay the circuit board down. I'm going to show you first of all how to replace the cord, shorten and replace the cord. Make sure that your soldering iron is hot enough to melt the solder and clean enough to do so. Way to do that is to test it by applying some solder to the tip. Make sure that it melts the solder. Okay? What I normally do is I apply a little bit of solder here, and you can see that as you apply it, it real cleanly removes the solder, pulls the solder right off. Now when you get a regular Nintendo controller in, they won't have the wires going straight into here. There'll be a little crimp on the end of that you'll have to deal with, but that shouldn't be any problem. So then these will just pull right out as you heat each one. Some of them will pull out without heating, others need to be heated to pull out. So now I've got them pulled out. Okay? Now what we want to do is find the affected area. Let's say that the affected area, for argument's sake, would be right here where the bend occurs, and it's been moved back and forth, and it's broken there. You take your wire snips and snip just below the affected area, and take this bad part and throw it away. You then take your wire strippers and you want to strip back about 1.5 inches to 2 inches of clean wires. There's a small cloth reinforcement line in there that you don't need, so you clip that off, throw that part away, and that leaves the 5 leads that you will need in order to effect repair. Now these wires are not ordinary wires. What they are is they're a wire with a cloth wrapped around fabric to give it extra strength and flexibility so it doesn't break. What I usually do is I strip back just a very small tip, probably 1/32 to a 1/16 of an inch. If you get this too small, it'll stretch the wire way out. So strip back just a little, about a 1/16. So now you've got them there. And what I like to do is form my little solder loop so that I can do direct soldering without having to worry about holding it. So I just tin. What you want to do is you want to tin the tops of each one of these wires. So make sure that it's straight, and then run a little solder along the top of it. So these are tinned now. So you have all 5 of them, and they're tinned. Get your circuit board, and it doesn't matter which one you start with. You can insert the red first of all, flip it over, and as you hold it with your finger, again I take my solder, form a little loop like that, and bend it down so that it'll touch the circuit board, and you don't need 3 hands that way. And solder enough that you get a good connection. You don't have to necessarily cover the hole, but enough so that you get a good connection. And go back, now that I've got the red attached, we want to attach the yellow. I don't know if you can see that or not. So we'll move out of the way here. The yellow. That's the yellow, where it says yellow, obviously. Want brown next. Again, you don't have to do it in this order. Brown is now attached, and we have white and orange. Got both of them there. Do both at the same time. Got white and orange detached now. Okay. So you see that those are complete, and they've been attached in the proper order. And you've now hopefully solved the wire problem. Again, a proper way would be to make sure that you've fixed the problem is to take your voltmeter and ohm out the colors back to the color corresponding here. Okay. So I'm going to detach the little connector. Now I'm going to show you how to replace the 4021. Most of you already know how. So you can, the way that I've made this is you can fast forward through it. Get your desoldering wick, your solder wick, clip off some clean ends. Now this is such that you can almost do two leads at the same time. If your soldering iron is just proper, and this soldering iron is a 45 watt soldering iron. It's a Weller 45 watt. So I like to put it right between two and slide it up, and it cleans two out at the same time. Then move down to a clean piece of braid and move those up. The next one, move up. So move. You can actually do two at a time if you do it right. Don't hold it there too long. Actually, on a bad chip that you're pulling out, it really doesn't matter. Spin it around and repeat the process for the other side. Apply it, slide it in, and it'll remove the solder. Slide it in, slide it in, slide it in. Now, removed the solder from all of these leads. If you flip the chip over and you have a small screwdriver, I'm reaching for one here, sorry. You can insert the small screwdriver here and gently rock the chip up, and it'll just slide right out. Most circuit boards have written on it IC 4021, and note the notch at the end here. The notch corresponds on the chip to the bubble. You want pin 1 here. If you get it flipped around like that, it won't work. Note the notch and note where the new chip goes. Now the new chip's feet will be a little spread, so what you'll need to do is kind of squeeze it so it fits in. Now we've got it to fit in there. And now we're going to solder it back and put the new chip in. Now again with solder, this is a new chip. You don't want to get it really, really hot. Just put enough solder on there and do it quickly enough that you've made a good solder joint. I don't like that smoke blowing up in my face, so I blow it away. Not a good idea to breathe it anyway. Cleaning the tip often to keep it clean. The way you clean it is just put it in there and roll it. I don't know if you can see that or not, but again, work your way down, solder each chip one at a time. So now we've replaced the chip. So we've checked the wire's alright, there's no breaks, no cuts, cleaned off the top of it. Our circuit board is ready to be replaced into the housing. A little bit of water still left in it, so I'm going to pause and dry these off with a towel, and we'll be back in just a minute. Okay, now what I've done is I've laid my towel back down here, give me the clean surface that I need, and I'm bringing the parts back in. Now you'll notice that there's still a few little drops of water here. That's won't hurt anything as long as you wait a few minutes before you plug it in and turn it on. As long as there's no power here, you you won't have a problem with the water. The way that it goes back, that's notched, and doesn't matter how that goes, you can get it in any direction. Then note that the black dots go towards you. You don't want them facing down like that or they won't make contact. That's actually metal that will actually bridge the gap on here when you push down on those. So that one's been replaced. This one doesn't have any buttons, it's just one unit, and note the notch hole here that goes over, so that goes like that. Then replace the two red buttons, A and B buttons, and the silicon membrane that goes over it, and now you've got all three of them back in place the proper way. Put the circuit board the direction it needs to go. There's some notches here that these retaining pins will hold it. Then feed your cable down through here, feed it back around. What it needs to do is go around, I don't know if you can see that, around those, through there, and out the opening. So now we've got a strain relieved circuit board. A little too much strain on here, so I'm going to pull it back a little. And there we go. And we've got it like that. So now, with the cord coming out, we're prepared to put the back on. Now as you apply the back, make sure the cord is directed properly. Everything's in place. Cord's direct properly. Place it on its face and replace the screws. Alright, next we're going to talk about the RF switch. Now, the back of the Nintendo has an RCA plug on the back where the RF switch plugs into. There's some problems that can be associated with that, which we'll cover later when we handle the control deck. But typically what happens, just like the controller cord, there's an RCA cord on the end of this. The RCA cord gets bent back and forth, put in here and gets bent back and forth, and you get a bad connection here, or you have an animal that chews on it. Now, and you've attached the RF switch properly to the television. You have your antenna coming in here and this going out to your TV, plugging into your television. What will happen is when there's no power here, there's two transistors in here that are switching transistors that when power is applied here, it actually cuts off this path to the television and redirects the Nintendo into the television, so that you now have electricity flowing in this direction while the antenna is shut off. Once the Nintendo is powered down, it turns this off and reconnects the direction to this direction into the television, so your antenna is hooked right back up to your television. Of all the units that I've repaired, the most common problem, again, is cord damage. If the cord is damaged somewhere in the middle, somewhere close to this, you can take the top off of this and shorten it. Again, cutting it here and shorting it here. It's a little tricky to get it back in here. If the cord is damaged on this end, again, you can cut it here, pull it short, and go into your neighborhood Radio Shack dealer. You can purchase an RCA plug to put on the end of this. And what I'm going to do is I'm going to actually replace this one to show you how to replace the end. Again, for those of you that are advanced and want to get to the control unit, you may want to fast forward. But for those of you that need this, I'm going to go through it. The other problem that I've seen, if you check this coax, it's also damaged, and you'll find that this tip has either been bent or broke off. Usually what I do in that case is I go down to a VCR shop and I buy a patch cord, and I simply take them that are preformed and I cut off about 6 inches of the end of one of the patch cords, F connector to F connector patch cord, and I cut it and solder it back into here. And so I replace this whole piece right here. And again, I'll show you how to do that in a moment. Most of the time, the RF switch is pretty reliable. I've never yet, of the 200 or some that I've done to date, I've never yet had to replace anything, knock on wood, anything inside this. So that's the theory behind the RF switch. Again, what you'll need to replace the RCA plug on the end, wire cutters, wire strippers, you'll need a little roll of solder, and then what I use are Radio Shack catalog number 274339. It's a set of metal shielded phono plugs. These are a little tighter going in than these are and a little more difficult to take out, but as you use them they get a little easier to use. So I'm going to lay that down and I'm going to open up the pack and pull out one of these RCA jacks. Now you'll notice that there's two pieces to it. The shield comes off, and you normally want to set that aside. Now, again, find the point where it's damaged. If this itself is damaged, you'll want to cut it off just as close to that as you can. But again, let's say that the damage occurs somewhere in here. There's a cat bite, or a dog bite, or a cut, or a burn, or it's been on the lamp or something, and it's right in here. So what we'll do is we'll cut it just past the cut. The cut would be up in here, and again we throw that portion away. What we want to do now is we want to take, and this is kind of tricky, you want to strip off enough so that the center lead, and I'll show you why that's necessary in just a minute, you want to strip off enough so that the center lead extends completely through that. So what I usually do is lay it next to it and measure it off, and then strip off enough so that that whole thing comes off at one time. Kind of tricky and takes a little practice to do it, but you want to cut through the coax and the shield, but leaving the inner portion intact so that you don't get a breach of insulation here. Then you want to come back about 1/4 of an inch and remove just the insulation from the shield, leaving the shield intact here, if we can get it. There we go. So now we've got about 1/4 inch of shield there, and we have our wire up front. Now the wire will, the center of the coax will fit through, but you'll need to strip off about 1/2 inch, 3/4 of an inch of that in order for it to protrude through the end of the connector. Now don't forget to slide the shield over the end of it. So slide the shield over the end so it's on there. And sometimes what I do is I tie a little knot right here so that the shield doesn't go sliding all the way down, and it's kind of a nuisance to have to get that a little later. So that's what it should look like, something like that. Now some people prefer, rather than to just hold the shield on with a crimp, to solder it. It's up to you, whichever you want to do. What I'll usually do is insert that through like that. You'll notice that it's sticking out of the end. Again, I prop my solder up so that I don't need 3 hands here. And you apply enough solder to completely close in the end, so that as you look down into the RCA jack, it's enclosed and there's no openings down in here. You then cut off the end of the wire that was sticking out, and you've got a good solid connection there. What I usually then do is rotate the end so that the shield is in contact like this, and this is where you'll need a pair of needle nose pliers. Take your needle nose and bend the edges down like that. Bend the edges down so that they're making good contact. So now you've got not only an electrical connection, hopefully, with the ground, but also you've got a mechanical connection with a strain relief. So then you can pull the shield back up and screw it back on. So now you've got a new end on the end of the RF switch where the old was bad, and you've now effected repair. Again, about $5 is a fair fee to charge to do a repair on one of those, since a new one is about $10. The tricky part comes when you get to this end of the RF switch. Inside is some small screws that need to be taken out, and I'll show you what's inside this. So we'll hurry here and take the screws out. Okay, remove the cover. You'll notice it's a pretty simple device. It just slides right out. Move the bottom cover out, and here's the circuit board. Again, what you've got a couple transistors, switching transistors here. You've got the TV signal coming in. You've got the antenna coming in this direction, and the TV going out this direction, and the Nintendo coming in here. And what happens is when power is applied to here, these three transistors switch and cut this off and send the signal from the Nintendo out to your television while your switch is cut off, and it provides enough isolation that the FCC is okayed it, that it will work okay. So it's a very unique device. But again, you don't need to use this if you don't mind using the manual switch. Now usually what happens is if it breaks here or in here, you can desolder this, and I'll take you through that here real quick, or desolder this. This is again a little more tricky. Under here there's a shield that not only provides an electrical connection but a mechanical connection so that it's hooked to the circuit board and doesn't move around a lot. Same here, as you can see, but this one is covered up with some heat shrink. This one is just exposed. So what I usually do is you lay that down, again, get your solder wick and get a good clean piece of it here. Am I getting to the end here? No, it just was attached. So get a good clean piece of your solder wick, clean the tip, and apply it to the area. Big enough piece that it's taken actually. Now there's two connections here that hold on the shield, and there's one connection here that holds the tip in. So you actually have to remove, desolder three positions. Now inadvertently, by heating this up, I melted and desoldered this connection. So we're going to have to make sure you look for that and repair any desoldering that you didn't intend to do. So here we now attach it, or apply it to this end of it, and we desolder that properly, and we'll desolder the tip. Okay, so now that it's all been desoldered, you can pull it right out. I don't know if you can notice the close-up here, but you'll notice on the close-up that you have a metal shield here that's holding the outside, and you have the center portion coming through here. So what you want to do, you want to bend these back, bend both of those back. Try not to break it. Bend that back, bend that one back, and then cut and strip identical to the way it is there. You may want to clip this off as a model. So we'll bend those back, being careful not to damage it, as I mentioned. And the way to bend them back is I usually take my wire cutters and just kind of inch them through like that, and that gives me enough to where I can pull it through, pull it back. And again, same thing up here, forcing it through, it gives me enough. So I've been able to keep the shield here. I did a little damage to that, but that's alright. We're not going to need that anyway. So theoretically we would cut this just prior to, or just above, just below where the damage has occurred and would throw the bad part away. Now, laying this next to the part we want, what we want to do is we want to strip and strip the insulation identical to that. So what we'll do is this one here we want to cut right through to the center. So we'll pull that one off. We left a few little braids here that we're going to cut off with our wire clippers. So we'll pull that back with our wire clippers and cut those off. So now we have that much sticking out just like that. And what we want to do is strip the insulation off the center there. Now what I like to do right here is to tin that part to give it a little consistency so it doesn't bend around and unravel while you're working on it. So now that that's tinned, what we want to do is we want to come back about a 1/4 of an inch, leaving enough insulation for it to make a firm mechanical connection, but taking enough away that it makes a good electrical connection. So there we have it. And now what we'll do is we'll lay that directly back down in, right where we pulled it out of. Just right where we pulled it out of. Okay? And using the needle nose, we'll crimp it back together, just like where we took it from. And there you have it. You have your end right from where we started. Bend that piece over. You've got a triple solder joint now. Throw that away. And it fits right back down in to where it pulled out of. See? So we've got a good mechanical connection. Make sure that your braids are cut off or back to where they're supposed to be. Okay, now you've got a triple solder joint to redo. So resolder the center portion of the coax. And now we're going to resolder the strain relief ground part of it. Let it cool down. Cut off any excess that might exist. And there you have it. You have a good connection cut off. You'd repeat the same procedure up here. I don't usually put the heat shrink back on around it. Repeat the same procedure here that we did here with this portion. Now you can do a couple things. This coax is not a solid center coax. It's a braided center. So unlike most coax cables, you can't just get an F connector, cut this off, strip it back, and put a new one on, because the center is braided. So that the center needs to be rigid enough to fit inside. So you can either pull this one off and get a coax that is rigid and reuse it, or you can pull this one off and go down, like I said, to a video place, or if you've got one laying around, just cut off about 6 inches of a VCR cord and reuse it. We'll check this one for continuity. Check this end. Touch it there. Touch it here. Getting good continuity. And touch it to the shield. Touch it to the shield, and we're getting continuity there. So we know now that the switch is good and that the cables are good. If there is a dip back upside down like it was when we pulled it out, making sure that the square end of this slides into the notch here to give it the proper relief. Feed this wire through this hole, feed that wire through that hole, and then we replace the top, making sure that it's there, and secure all screws. Alright, let's talk about the NES control deck. Probably many of you are waiting just to hear about this, so I'll get to it. First thing you want to look for is any physical damage that has occurred to it. Scan around, see if there's any chips or anything, any cracks. If there is, you want to make note of that and give it back to them in the condition that you received it. cleaned up a little, obviously. Some of the doors are broken off. That's all right. If a door is broken off, it's just a dust cover and doesn't affect the play at all. So just make a note of the condition that it's in. The first thing you want to do when you get a system in is remove all cartridges and plug the unit in the back, with not hooked up to the TV or anything. Without a cartridge into it, turn the unit on. And what you should get is a flashing light. There's power to it, and with the flashing light like that, that is the symptom that I mentioned earlier on the cartridge. It doesn't see that the cartridge is there, so it keeps resetting itself. Okay? That means, what that will tell us, that tells us that the AC transformer is good. And then it's not the AC transformer. If you don't get a flashing light, then there's something wrong with the integral power circuit. So first thing you'll want to do is remove the connector. Get your voltmeter that you have, turn it on, turn it to voltage, and you want to check to see. This is an AC adapter, and it puts out AC voltage. So your voltmeter needs to be on AC volts. You should get somewhere around 15 or so volts. I'm sorry, 10 or so volts. Plug it in, insert one lead into the center and one lead here, and you should read a consistent of about 10 volts. It may fluctuate a couple volts depending on the manufacturer, the subcontractor that made it for Nintendo. So this tells me that the AC transformer is good. If the AC transformer is good, then the problem is somewhere else in the unit. Turn it on. Again, you should get a flashing light. So I know that the power is good. Next thing you'll want to do is turn on a television. Turn it to whichever channel that you need to. Now back here is a 3/4 channel 3/4 switch. Next thing you should do, as I mentioned, is hook it up to a television. There's a 3/4 switch here, so depending on your metropolitan area, if you have a channel 3 or a channel 4 that's broadcast, you should switch it to the other channel. In my area, there is a channel 3, so I use channel 4. Make sure that you have that switch set correctly. So switch it to 4 or to 3. As I mentioned, I have mine set on 4. Plug it in and get a game that you know is good. In this case, Breakthrough. Turn it on and see what you get. Now, one of the symptoms that most people get is a flashing screen. It'll just flash even with the cartridge in, and it won't play even with the game in. It appears the same as if the game is not in, and in reality what's occurring is that the connector is been pulled back and the contacts are not being made properly, and it actually thinks that there is no cartridge inside. I'll show you how to fix that in a few minutes. The other symptom that people will complain about is that their screen is snowy. Now, when you insert the cartridge and you turn it on, you should get a very clear, strong signal. In other words, notice the snow on your TV. When you're on channel 3 or channel 4, whichever one you're on, there should be snow. As soon as you hit the power on, you should immediately get a screen. Even if it's black, even if it's blank, even with no cartridge in it, what will happen is it should go completely blank with no snow at all. If it's snowy at all, and by turning this on and off, if you don't see an abrupt change in the TV screen, then there's something wrong inside with your RF switch, and we've already been through how to fix that, or with the connector, the RF modulator connector, which we'll cover that in just a moment. All right, we're going to cover some things right now that I think are important. So what I'll do is, first of all, we'll start off by the proper way to disassemble a NES system. First of all, make sure that all the power is disconnected. Power and the coax to the RCA plug. Next thing you want to do is flip it over. One nice thing to have is a cordless screwdriver. I prefer the elongated, the linear kind, because it's easier for me to handle. This one pushes and makes into a handle type, but I don't like that as well. It's according to your preference. But these make it very, very easy for you to disassemble these very rapidly. There's 6 screws on the bottom, as you can see. With a power screwdriver, it comes apart very quickly. With experience, you'll be able to tell when the screw is out of its hole and when it's just spinning at the top of the hole. Okay, so what I usually do is I loosen all the screws and I take it out, leaving the lid in this position. Then I turn it at an angle and I hold it like this so that the 3 bottom screws fall out into the lid, and I can catch the 3 top screws with my hands. Now that the 3 top screws, sometimes they don't come out, you have to push them out. The 3 top screws and the 3 other screws are out. I can take the lid off, and what I've done is I've labeled a small, this is just a butter margarine plastic dish. I've labeled it small because most of the screws in the Nintendo are the same size. There are 2 screws out of all the 20 or so that we're going to take out that are different, but all of these are the same. So I put those into a small little bin called small. Now at this point what I do is I usually evaluate the lid to see how dirty it is. At the beginning of each day I get a bucket of water, just put some dishwashing soap in it, warm water, and I draw that. Now what I'll do is while I'm working on this, I'll drop this in the warm water and let it soak. There's nothing that can be hurt by water or soap. And while this is soaking, if there's any goo or gunk on this, it'll loosen up and you'll be able to scrub it off and clean it up so it'll look real nice. Sometimes there's stickers on here too. You can pull the stickers off if there's any residual adhesive. What works nice on removing that is WD-40. Spray it with WD-40, work it in with your finger, let it set for a few minutes, and then it'll usually wipe off with either a Kleenex or a paper towel or something. Okay? So I'm going to take this and set it in the bucket of water. And earlier, what I like to do is get a bucket, just a gallon bucket of warm water, put in some dishwashing fluid. In this case, it's just Kingston liquid dish detergent, and the lid will fit in just right inside this bucket. I usually fill it up enough that I can still get in there and work, but I have enough warm water to cover this ribbed part. This is the usual part that gets real dirty. Okay? And I keep a brush close by, and when this has had a chance to soak, I use the brush to go back and forth, get inside the ribs to clean it. I can do the sides with it real quickly, so that now the lid is clean. I then rinse it off with clean water. And you may want to, this may take a little while for you to clean, depending on how dirty they are. But this is just a little nice little add-on I do for each one that I repair. Then I set the lid, I let it set for a few minutes down on the floor. I put it down on the floor and let it set while I'm working on it to dry off. Okay? So we'll set that down there and we'll come back to it in just a few minutes. Okay, now we're going to get to the guts of the NES control deck. We've already removed the 6 screws from the lid. Put them in here. Now there's 1, 2, 3, 4, 5, 6, 7 screws to remove the RF shield. Sometimes there's an 8th screw in this lower right hand corner, but most of them only have 7. So again, remove all 7. Placing them in the little dish. Okay, now once those 7 are finished, or removed, you can remove the top RF shield. All it is a piece of metal that's been bent around to fit down on top. And this shields any radio frequency interference that might be given off by the Nintendo that would interfere with your television. So what we'll do is we'll set that aside. Sometimes that's real dirty too, and that has lint or dirt or something on it. You can just brush it off, brush the lint off the top of that with a rag, and then I set that aside for later. Now what we've done is we've exposed the insides of the Nintendo. You'll notice that right here, this is the game loading cartridge. I want to make a point right here. The way that the Nintendo works, you have a 72-pin connector that's deep down inside the Nintendo. As you insert the game into it, and as you push the game down, the game goes into the connector, and then as it pushes down, it levers. There's a lever action there on the connectors. Okay? Now the door, as you know, sits right here, and that shields it from any dust getting in. But if the door is not there, you'll get dust in this part of the Nintendo, which is sometimes bad. However, the connector is recessed far enough that you don't get a lot of dust or dirt that floats down in there. Most of it is introduced by the contacts, via the contacts. The cartridge will sit out for a while, dust will settle on the contacts, and then it's inserted and the dust will transfer from the cartridge into the contacts. So that's why the little dust cover that Nintendo gives you is important to use, and to keep these in a clean spot. Now at this point, you can take, if you just suspect that the connector is dirty, you can take one of the cleaners that I've sent to you and insert it and just move it in and out, and back and forth, in a back and forth action. And what that does is that cleans the contacts. It will clean off any dirt that's on the contacts or remove any hair. Okay? Now one of the biggest problems that I mentioned earlier is the flashing screen. About 90%, 91% of all the Nintendos I've gotten in have the same singular problem. And that is that the 72-pin game connector that hooks onto the motherboard is usually dirty or worn out, in most cases worn out, and needs to be rebuilt or replaced. You can replace them. Again, the address of where you can buy these for replacement is included in the documentation. However, at the time of the making of this video, the price was around $20 to $25 depending on the volume that you buy. So what I've done is I've invented a technique to rebuild these. And the technique, you can take any cartridge, any 72-pin connector, any 72-pin connector, and rebuild it stronger and better than the original. So I will show you that technique in just a few minutes. To finish removing and disassembling it, there's 2 screws on either side of the RF modulator that must be removed. Again, what I keep on hand is a little picking tool, and it's easy now to reach in and pull those screws out. Again, these are the same size as all the other screws. We've removed 13 so far. That's the 14th, and now this is the 15th screw, and they all are the same size. I put them all in this small bin. Now these 2 front screws that hold in the loading cartridge are again the same size. So they'll go in the same bin. Remove those, put those in there. And the very back two screws, the very back ones, this one on the right and this one on the left, are also the same size. Now, the only other two screws that you'll have to worry about are those, the screw here and the screw over here, the middle ones. And those two screws are not the same length as these. So, I have another little bin here that I have appropriately labeled long, and what I do is when I pull those two out, sometimes they're the same color, but usually they're a silver color versus a copper color. I will put those in this other bin to keep them separate from the others. Now that that's been done, I can stack these and move them to the side. The entire insides will just lift right out. And again, you'll have to experiment with that to get used to lifting it in and out, to moving it around. Once you lift it out, this is the kind of tricky part. It's connected by three connectors. The leftmost game controller, this is the game controller, hooks to the front connector. And it hooks with the purple onto the left and the brown on the right. Okay, so the way you get those out is you just pull on it. I haven't found a better way to get those out other than just pulling on it. Now there's a sharp edge right here, so I kind of rock it back and forth as I pull, and that comes out. Now that's the on-off switch reset connector, and that ties in over here. Okay? And then the right game controller plugs in just right next to the game controller, or to the on-off switch reset switch. And again, I rock it back and forth as I pull it. Now this is free to move around, and the bottom, you'll notice, is comprised of a couple things. There's a bottom here, and this plate comes off. And a lot of people ask me, why is that plate there? Well, it turns out Nintendo, the authorized center up in Washington, has a computer, and the computer, they pop this off and they break this little cover off and take it off. Their computer plugs directly into the motherboard, and they can troubleshoot a motherboard in just microseconds. Whether the RAM's bad, the CPU, any of the chips on there, they can tell it right away. Unfortunately, we're not that sophisticated, nor do we have that money to invest. Therefore, we won't worry about that. However, there is the assembly here for the reset power, which comes out also. Only remove these if the bottom is dirty and needs to be washed. Take these off. You take these off by taking these two screws off, these two screws out. This, I'll go ahead and do that for you. Take these small two screws out, and I usually just put them in the same bin with the long screw. Okay? Now this cover hinges from the bottom and pulls off the top because there's two little levers here that have to fit down. Okay, like that. So pull that off. Now, there's a left and a right one, and you'll notice that they're not the same length. If you hold them side by side and stretch them out, one is longer than the other. Okay? They're interchangeably, electrically, there's no difference. The only difference is that one is a little longer than the other. Okay? So be sure to put those in right. It won't hurt if you get them mixed up, and they'll reach to either side, but the short one goes on the left and the long one goes on the right. Now you'll recognize this from our earlier troubleshooting of the controller. This is what I use to troubleshoot the controller. I have a couple of junk units that I've been able to take parts off of, so I keep this handy, and I use that to help troubleshoot the controller with. Whether you have the resources to do that or not, it's up to you, but I went ahead and got one unit that was pretty well trashed, and I use that to troubleshoot with. So I'm going to put these back in real quick. Okay, cover goes back on by hinging to the top, going to the bottom, replacing the two screws. Sometimes those are dirty enough that they need to be washed. They need to be washed off. Okay, so screw that back on, and screw the other back on. Okay, there we go. Now, the way that the power and reset comes out is there's a screw here and a screw here, and they just kind of lift out. You have to kind of tilt it and lift as you pull it out. And these get pretty dirty sometimes. Be careful when you wash them off not to get a lot of water in the switch itself. What I usually do is I take it apart. I have one over here that I use for troubleshooting that I've taken out of another one, the same one that I got that controller socket out of. And what I usually do is I just pretend this was water. I dip it in about like that and then just wash it off with a towel, paper towel or something, toothbrush. Get that all clean and avoid getting water up inside these. It's just not a good idea. Okay? So now that that bottom is out, I usually set that aside for later assembly. I leave it like that. Again, if it needs to be cleaned, remove all these and you can immerse it in the same water that you wash the top with and clean the top and the bottom. These stickers are metallized stickers and they won't come off even if they get wet, unlike some others that are paperized. So don't worry about these stickers coming off. Take note of the serial number on the bottom. Okay, so I'm going to set that down. So what that leaves us with is the RF shield for the bottom, and now this just lifts right off. It's a little tricky getting it back on again because you have to make sure that this bottom connector is inside the opening. So it slides on, again pulls off. Again, I'll set this to the side and we'll use that later. Now, the cartridge assembly slides forward and off. Okay? You'll notice that once you put it back on, you need to be careful that this little lip is properly seated right. If it's not over the motherboard, if it's like this, then you won't get it correct, and when you screw it down, it'll cause this to bend and this won't index properly. Okay? These things, when you push down, it should hold down, and then when you let go, it should push down again, it should come up. And sometimes I've had to work on the mechanism in here to fix them. You'll have to kind of experiment with that and find out what's the best for you on repairing those. But usually these can be immersed in water if they're dirty and cleaned up. Again, with a toothbrush or something to that effect. Set that aside. Okay, so what that leaves us with now is the main circuit board, okay, and the 72-pin connector. So what I'm going to do is I'm going to pull the 72-pin connector off. Now note that the 72-pin connector goes on the solder side, not this side. And it's easy. It will go on this way, but it won't work. Okay? So when you need to, put it on this side. When you need to put it back. Now, it is okay at this point to go ahead and insert a cartridge for test purposes. However, that's why you need this on-off switch. Hook it over here, like this. And if you're going to play a game, you'll need a controller, one of those controller things to hook on. Then hook the coax cable here and the power cable here, and you should be able to turn it on and get a solid red light, meaning that it's making proper connection here. Turn on your television and see that everything works fine. If it doesn't work fine, then usually there's something associated, obviously, with what's left. Okay, at this point there are three major problems that occur with, if a problem exists, there are three major problems that will probably solve 95% of all your troubles. Again, to this point we've troubleshot the AC adapter, the RF switch, and the controller units, and the game. So we know that it's not there, so we know that it's in here, right? So what you want to do is turn it on, and if it still flashes at this point, the biggest problem you'll encounter is the 72-pin connector. The 72-pin connector, what happens is these contacts, the contacts in here, get dirty or they oxidize, but the biggest problem that occurs is they recede. They lose their spring and they move back away from the circuit board. There are circuit boards that you'll get in, or units that you'll get in, that no matter how good you clean them, you'll never, ever, ever get them to work. So you have to either get a new one or rebuild them, and I'll go through the rebuilding process in just a moment. To clean them, first of all, as I showed you before, just insert the little wand and move it up and down and back and forth. The top portion you have to be very careful of, because you can grab the side of one of the fingers and bend it if you're too aggressive. The bottom part, though, you don't have to worry about it. What I usually do is I just insert it and move it back and forth. I insert it at an angle so that the point is in, and that gives me, going this direction, an edge, and going back this direction, an edge to move smoothly across. So I clean the bottom portion of the connector with one of these cleaning wands, and you can see by the dirt on this one how dirty this one was. Now the top one, you usually can look at it and tell if there's any oxidation. It usually shows up in the way of a green little corrosion on some of the contacts. If there's a lot of that, you may want to get something like a straight jeweler's screwdriver and move it back and forth and scrape that off. Okay? The next thing you want to do is rebuild the top portion of this connector. And I will show you in just a moment. I'll zoom in and we'll do a step-by-step. I'll take you through how to rebuild one of these connectors. And that's where you're really going to make your money. Without having to pay the $24 for a new one of these. This, incidentally, is a patented item. Nintendo has a patent on this. So I've tried sourcing this out of Korea, out of Taiwan, out of China, out of Japan. You can't get it anywhere. All my suppliers come back and tell me that this is a patented item. So you can't get that. So the choice is you either have to go to Nintendo and pay the exorbitant price of $20 for this thing, $25, or you get it on the black market somehow and pay a portion of that, which some of you are doing now, or you can rebuild it. And the rebuilding takes some time. Once you get good at it, you can rebuild one in maybe 10 minutes. About 10 minutes it takes. So I'm going to set that aside, and we'll rebuild one here in just a moment. The other two major problems that you'll encounter are, remember when I showed you when you turn this on, if the screen doesn't definitely change from a snowy to a real strong solid TV screen, then usually you've got a problem in the somewhere in the RF portion of your control box, your RF modulator here. If you've checked out and made sure that the cable is okay, the next most common failure occurs in the RF modulator itself. Now what I'm going to do is I'm going to take off the bottom cover of the RF modulator. If you look in here, right at this point there is a wire that is soldered from that spot that must go up and turn at an angle and be connected to the very center of this RCA jack. What happens is over a period of time, the mechanical connection on the outside of this barrel of this RCA comes loose. It's allowed to spin. Okay? So when your customer inserts and pulls out the RCA plug, this is allowed to move around because the mechanical connection has been degraded sometimes. Other times, it's just been built too small inside. So when this is inserted inside, what it does is it actually hits that wire and pushes it and breaks it. So the wire, if you looked inside, the RCA plug is here and the wire is like this. And sometimes you can move it around and get the two to touch. But there's physically been a break in that wire. So the first operation is to go in and repair that wire. And that'll reset. Another way of telling is the red and the yellow jacks on the side of the RF modulator are composite video and composite audio out. You can take a patch cord, plug it into here, plug it into any VCR that has a composite video and audio input. It'll say in audio, in video. Get the patch cord, plug it right into your VCR, turn on your TV, set your VCR from tuner to direct input, and now you can turn on the Nintendo and you'll be able to play your game through your VCR. So the composite video and composite audio is now feeding through your VCR. And that's a good way to troubleshoot and tell whether that wire is broke or not. But chances are, if it's a fuzzy picture or if it doesn't give you a strong clearing of the television band when you turn it on, that wire is broken. So first thing you need to do is check to see if the barrel is loose. If the barrel is loose, you need to get your soldering iron and very carefully and quickly tack maybe 1, 2, or 3 little solders around the outside of this barrel. And do it very quickly so that you don't melt the plastic here. Very quickly, I mean, I'll show you how to do it. I'll move the camera up here in a minute, and I'll show you how to do that. Now, the next thing is once that's secured, and in this case it is secured, there's no movement of the barrel connector. So what you need to do is, the next thing you need to do, and the proper way of doing this, is to take the RF modulator completely off. This is a board, as you can see, that has the RF modulator removed from it. That's the optimum way of doing it, because then you can take the lid off, the other side lid, like we took this one off, you can take the lid off of this side without any problem. The problem with that is it's a pain in the neck to get in there and unsolder these. If you'll notice on this motherboard, there are 5 connections, 1, 2, 3, 4, 5, in addition to the ground connections here. So there's 3 ground connections that you must hook up and 5 printed circuit board connections. The 5 printed circuit board connections are plate throughs. They go all the way through into the other side. And this is where it's real important, right here, that the connection be made. Unfortunately, that's not where you do the soldering. If the plate through is destroyed, it's very, very difficult to reattach the RF modulator. You can't sit here on this side of the board with your soldering iron and apply enough heat to get the solder to melt through and make a contact on this side of the printed circuit board. It's very difficult. So I avoid that in any way I can. I avoid pulling the RF modulator off. I've pulled out too many of these plate throughs. It doesn't work. Not a good way of doing it, in my opinion. So what do? Well, for me, the next best thing to do is to bend this plate back. So take the front completely off, and then what I try to do is bend it as far back as I can get it to bend. So I bend it like this, okay? Now, I'm going to stop the camera at this point, move it forward, and I'm going to show you what the RF modulator looks like. This is a close-up of the RF modulator with the top pulled up. I'm going to try to get it up here close, and I'm going to have to adjust the macro lens here. But you see that I've bent the lid up so that it exposes the insides of the RF modulator. And you'll notice that right inside here, you'll see the little wire. Let me get it up here close where you can see it. You'll see the wire that is soldered from the insides of that RCA jack, the little white wire there, jumps from that solder joint down to the printed circuit board underneath. Remember, we took the cover off a few minutes ago. I put it back on here for you, but so it goes from this solder joint right here, that little wire comes around and has to hook on right there. Okay, right there. And usually what happens is because this spins, or this was soldered too close up here, it breaks. And all you have to do is get a new wire and replace that one, or take that one, strip it back a little ways, and pull it up and resolder it right there. Then you can test it again. But make sure that this is not still spinning, or you'll have the same symptom within just a few months. Okay, that's it right there. Okay, so now we put the cover back on the bottom of the RF modulator, snap it back on. and we bend this back down again. Sometimes you'll have to insert a little toothpick or something in there to get it to lever to bend down properly. But you bend down, usually it'll close back up again. And you can now test it in this mode. Again, attaching your on-off switch to the side. You'll need to attach the on-off switch to the side. Power, coax cable, hook up your connector, insert your Urban Champ cartridge, whatever it is, and then turn it on. Okay, now the next, the number 2 problem that you can fix is what's wrong with all of these motherboards right here. If you look at the unit, the front of the unit, the NES board, there is, this is called the CPU board, and there's various rev levels, revisions. I assume there's 1. I haven't seen a 1. I've seen a 3 and a 4, all the way up to 10 or 11 now. This happens to be a 7. Regardless of that, they all have the same chips located in the same location. These 2 chips are called SRAM chips. This chip here services the PPU, or the picture processing unit, which is this chip here. You'll notice that this chip is removed. I have taken the chip out and put a 40-pin IC connector in its place. This is the CPU, and the SRAM here services the CPU. Okay? So, the CPU, the SRAM, PPU. Alright? The most common problem is the PPU will go bad. And when you turn it on, you'll get a garbage character. You'll get a logical progression, or at this point, you'll get a garbage screen. Now, a garbage screen can also be caused by a bad connector. So you have to make sure that you have a good connector and a good game on. Once you're sure that that's there, it'll show up as a bad screen. So what I'm going to do is I'm going to put one in that has a bad PPU in it so you can see what it looks like. Alright, this particular motherboard has a bad PPU in it. So what I'm going to do is I'm going to attach the 72-pin connector to it. I have a game that I've removed from the cartridge that makes it a little easier to work with that I insert. Now I can add on the on-off switch. I can add on the coax cable and the power cord. Turning it on, this is called Bayou Billy. Okay, now let me get you a game that most people are familiar with, and that's Duck Hunt Mario Brothers. Pull that one out. Put this one in. Okay, now you'll notice that the screen appears to be somewhat normal. There is a line running through the back of Mario, and there's lines that appear throughout the screen. If you go ahead and played this game, if I attached a joystick here and went ahead and played this game, the game would play, but there would always be, the screen wouldn't look correct. Now you can get the same symptom, as I mentioned, with a bad connector. So you have to make sure that you get a good clean connector in there. Once you've got a good clean connector in there and a good game, and it still shows up as the symptom, chances are you've got a bad CPU or a bad PPU, picture processing unit, and that's the chip that's on the motherboard. It will also show up as just a blank screen. The screen will come on, it won't flash, it'll be solid, but it'll be just one color. Or in this case we have a black and white TV, so you cannot see the colors, but it'll just be a single color like red or blue or green, and it'll stay there. That also, chances are, it's a bad PPU. So what do you do in that case? Well, let me get a motherboard over here that I can work with. As I mentioned earlier, this is a CPU. It's Nintendo's part RP2A03G. This is the PPU, and that's Nintendo part RP2C02G. So this is 3G and this is a 2G. They are a member of the 6500 CPU family. Unsolder using the method I showed you for taking out the 4021 chip in this controller, unsolder the bad PPU, replace it with a socket. I always recommend you replace it with a socket. That way, if you put it in and you burn it up as you put it in, you don't double your work. You can pop it out, and it also you can't ruin an IC socket by overheating it most of the time. So I socket these, and then I'll put a PPU chip in its place. Okay, so that's the second problem that occurs with the motherboard that you can fix. Now, I wanted to mention earlier that this little chip right here, it's got a label on it, the 3193A. It's called the CIC chip. Now you'll note that chip, that CIC chip, is the exact same CIC chip found on the game cartridge. That chip and this chip work hand in hand. Here's what occurs. The motherboard generates a 4 megahertz cycle, 4 megahertz, 4 million cycles per second signal. It pulses it into the CIC chip on the motherboard. The CIC chip on the motherboard sends it out directly into this, the CIC chip on the game cartridge. The CIC chip on the game cartridge then does something with the signal. I think what it does is divides by 100 and pulses, does a one-shot every 100 cycles. It then sends that signal back out, its pins, to this one. And pin 7 is hooked up to pin 7, I believe, of this chip. If any of those signals aren't there, this chip, the CIC chip, is tied into the reset circuitry of your motherboard. So what occurs if you get a cartridge and it's an unauthorized cartridge without the CIC chip on it, what will occur is you'll get a blinking screen every so many pulses. The Nintendo will reset itself. So you hit the reset button. That's one way of resetting the system. That's a manual reset. But Nintendo also put in a secret circuitry that will reset automatically if that chip is not present on the game cartridge. Now there's a way around that. The way around that is if you desolder this chip and remove it completely take that chip out or cut it out and pull it out, the Nintendo will still operate properly. You'll still be able to put a cartridge in and it will still operate properly. However, you won't be able to reset it. You won't be able to hit this reset button and reset it. You can turn it off, turn it back on to start the game over again, but you cannot hit reset with this chip removed and have it start all over again. So what I'm going to do is I'm going to set this unit up, and I've got this special cartridge here where the CIC chip is there, and I'm going to pop the CIC chip out and show you what occurs without the CIC chip in it. Alright, I have this unit set up. It's a good motherboard. Everything's fine on the motherboard, but I've got Bayou Billy, the game Bayou Billy, loaded in here, and you'll notice that it's operating fine. The light stays on constant, and everything's fine. Now I'm going to turn the power off, and all I'm going to do is I've socketed the CIC chip. I'm going to pull off the CIC chip, okay? And now I'm going to turn it back on again. And Bayou Billy comes on, but every so many cycles of the clock, because that special Nintendo chip is not on the game cartridge, it senses that it's not there and it resets every so many cycles. So that's what you'll get. Okay? So we turn it off, and I'm going to put the chip back on again. Turn it back on again, and you'll notice that everything's fine. So that's the symptom that you'll get if you try to use an unauthorized cartridge. Here, I have a unit I just got in that's got a bad connector on the inside. So what I'm going to do, I'm going to put this in time-lapse photography and let you watch me take it apart. Once I get down to the connector, I'm going to give you detailed instructions on how to fix it. Show you how to Okay, I have a few minutes left to show you how to rebuild the connector. Okay, the first thing I do, as I mentioned earlier, is take the bottom part and you scrub it off with one of these scrubbers. Cleans these bottom connectors. Take the top part and also scrub it. Also, it helps get out any dog hairs or anything that might be in there. You can even take one of the edges like that and scoop out any dog hairs or lint or dust or dirt that might be in there. Rub it back and forth. Visually inspect for any oxidized connectors. There aren't any. So the next thing you need to do is the rebuilding process, and here we go. Now what you're going to need for this is a drill press, a soldering iron, some fishing line. What I use is some 20-pound test fishing line. Okay? And then I've taken some 20,000 steel rod, push rod that I got at Ace Hardware and cut into 6-inch lengths. And then I pounded and flattened the end of one. So I have a long needle that looks like this. The first thing you do is you be twofold. We want to get those connectors back to where they should be so they're making good contact on the game cartridge as it goes in. And number two, we want to reinforce it so it never recedes again. Okay, and that's the purpose of this whole thing. The bottom ones are relatively simple. I take this piece of steel wire that I've got and I flatten the end on. And I just put it underneath each one of the connectors one by one and gently pry up each connector. Okay? Pry it up back to where it's higher than the ones around it. And don't really crank it up. It should just be above. You'll notice there's a little plastic fin in between each one of these. It should be just above the plastic fin. The blunted end of this wire and inserted it under each one of these and bent them up just a little. Not a lot, but just a little. You can see how well you've done by inserting that and looking the other side. Some of these are a little too high and you can push back on this side to get them back to go back down again. But they're free to move on this side when you insert the cartridge and it moves around. So you won't have much of a problem on this side. Just make sure that they're clean. The top side, again, is a different story. They're real tough to get to. They're recessed. So what we're going to do, as I mentioned earlier, we go 9 millimeters back and 4 millimeters down on either side. 9 back, 4 down. We're going to take our hot soldering iron and we're going to, right where that junction is, we're going to burn just a little starter hole. Some of you may want to use a scratch awl or something, but don't pound it because that stuff can crack. It's hot. It's hard and will crack. So I use a soldering iron and I burn a little hole there. Now I'm going to unplug the soldering iron so we don't burn anything up here. So now you see we've got a little starter hole here on either end. Now what I'm going to do is I'm going to take it to the drill press and I'm going to drill a 3/8 inch hole in each side. Now, it's a little tricky there because you only want to go 3/8 inch deep. A 3/8 inch hole and 3/8 inch deep. If you go too far, you'll interfere with these connectors and screw up the connector. So I'm going to show you the drill now. Alright, now I'm going to explain what I'm going to do first because when I turn the drill on, it's a little too loud for you to hear. I'm going to use this polishing as a little buffer in case I need to raise or lower this. But what I need to do is I want to make sure my drill stop is not deeper than about 3/8 inch. If I go too deep, I'll hit these connectors. So what I'm going to do is make sure that I don't go too deep. Now you can also tell as you start to drill through, there's a point where you'll break through and you'll feel that the penetration becomes a lot easier. It's at that point you want to stop. Don't go any farther. It'll be pretty hard going for a little while, and then as soon as you feel it break through, you'll feel a little grip with this. You know you've broken through and stop drilling. There I went. I felt a little snug. I felt a little snug pop, and I went through. So now you can see, you can actually look through there and see the contact, the upper contact from the side. Now we're going to do the same thing to the other side. Turn it on, and drill through the other side. Again, 3/8 inch. You don't want to go too deep. And be careful that you don't go be careful that you don't go all the way to the contact. There again, I can look through. Now I can look through, and I can see all the way through, and I can see the upper end of those contacts. Okay, our next purpose, the next goal, is to get this fishing line. What we want to do is we want to weave it through underneath the upper connectors, so it's between the upper connectors and the plastic, to give it a little distance and to give it some resistance so it will never ever recede again. Well, how do we do that? Well, the way that I've come up with it is you insert one of these push needles, or lifting tools as I call them, inside on the one end, and you push it all the way through. Well, how do you do that, you might ask? Well, one way is to you can insert this underneath the top one, and then using a pair of pliers, just a regular set of pliers, you can push it all the way through, gently pushing it through, and you can feel it as it glides through. That's one way of doing it. Some of them, you can see here, I'm pushing it little by little as it slides through. So we put the flat edge this way, and now we're weaving it through, and you can't see it, but it's going underneath. From this one end, it's going underneath all the connectors. Another way of doing it is this lifting tool that we have available also. You can order this from us. It should, if you, it's not listed in your appendix, go ahead and send it to us. Go ahead and send your inquiry to us. But insert that in like that and push on it, and it'll lift those up to where you can insert that thing and push it through. Once you're through the first 36, you push it into the second 36, and you can push it all the way through now, and it'll come out the other end. Okay, so now you see that we've been able to push this, and if you examine it very closely, you'll see that it's underneath all the connectors, and it's come out the other end. So we've got it out one end and out the other. Now what we've done is we've taken a smaller diameter. This, I believe, is 25 thousandths or 30 thousandths. You can get these tools from us also. I've taken a smaller diameter. I think this is 15 or 20. And what I've done is I've flattened the one end, and I've super glued some of this fishing line onto the end of it, and then with a razor blade I've tapered it so that it's smooth and it'll pull through. Once this is in there to hold the connectors up, what you do is you feed the smaller hole now, or you feed the smaller steel wire in through the hole, whereas this is now holding it open. Now that it comes out the other end, grip it with the pliers, and you twist it so that the joint is sideways. The purpose of this is if there's a weak joint, you don't want to expose it to the blades or to the ribs. You want to keep it against this other steel rod so that it's smooth and doesn't grab it and pull it out. So what we'll do now is we'll pull this through, and it comes out the other end. And now you see what we've got is we've got a fishing line underneath all 36 of the upper connectors. Now we just grip this other one and we pull it right out. And so now we've got the fishing line underneath there. So what we're able to do now is we'll cut this off using either a razor blade or some wire snips, and we've accomplished what we've set out to do. We've rebuilt the connector. We've cleaned the bottom connectors, raised the lower connectors, and now we've inserted a line through the top. Takes a little getting used to, and you may ruin a couple of these while you do it, but eventually you'll get pretty good at it, and it'll indeed pay for itself. So now what I'm doing is I'm going to clip the wire, clip the fishing line. You'll see that the fishing line extends out both sides about 2 inches. That's okay. You want to leave it like that. Leave it like that. And now I'm going to put the excess fishing line. What I do is I put about 6 feet or so on there. Then I can use it over and over again for multiple connectors. Now you see that this one is rebuilt and ready to go back in the machine. Again, insert our cleaning cloth gently move it back and forth. As I mentioned earlier, it's easier to catch one of these fingers and bend it. So you want to be careful on that. Move it back and forth and back and forth and back and forth. And now that it's clean, we'll reassemble. I'm going to go backwards, and I'm going to do this in time-lapse photography. I'm going to reassemble it so you'll be able to watch. We have the unit back together, ready to return to the customer. Clean top, everything's been cleaned on it. Check the front, make sure the front's fine. You can wipe it off now with a wet rag or a clean rag, and it's ready to return to the customer. We marked the serial number down in my book that I've repaired it, give them a 30-day guarantee, and I put my name and phone number on the bottom so that now they can call me back if they have a referral or if they have any trouble with it. I've already tested it to make sure it worked. Turned it on, and you should get a screen. The thing to remember is because this is a rebuilt connector, it'll be a little tight at first, getting them in and out. Cartridges go in real tight. Nintendo intended this to be a zero insertion force socket. However, it worked fine for a little while, but it doesn't work indefinitely as a zero insertion force socket. So therefore we've changed it to a socket that requires insertion force now, but what it will do is it will loosen up as you use it. So let the parents know that. Another way of loosening it up is to keep the connector, you just keep a game in it overnight or so and it'll loosen up. Is the game cartridges themselves. The game cartridges tend to get a little dirty, and you can tell by looking at this end, and you can tell by looking in there how dirty that they are. I'll show you the way that I clean them, that I think is the proper method. With your kit, you should have got a couple of these. It's just a popsicle stick with a cleaner cloth on the end. Very, very good for cleaning contacts and for the games. If you don't want to invest in a game opener, which we also sell, it's a little connector that goes on the end of a 1/4-inch spinner for taking apart the games, and I'll show you how to, I think, the best way to clean a game. If you don't want to do that, you can get one of these and simply rub this along the edge of either cartridge, and you can see how dirty that is, and you can see how much dirt there was. Now, Mario 2, the Super Mario 2, which is a trademark of Nintendo, incidentally, it was dirty enough earlier that I couldn't get it to work. So one thing you may want to do is, it says not to use any alcohol on it, but what I like to do, I like to take these little cleaners that I provide, and the way that I provide them is with quite an extension on the end, and this is so that you can get inside the game and clean them, and I'll show you how to do that a little later. But once you've done that, what I like to do is cut away the flimsy end, and what that leaves me with is a pretty solid piece here. And what I do is I like to apply a little alcohol to that, not much, and this is not the proper way to apply alcohol, but I like to apply a little bit to that, a little dab, and kind of cut it in a point shape, and that'll let you down on that as you clean it and move it back and forth, both sides, and that way you don't have to take the cartridge apart. This is actually a cloth that is used in polishing silicon wafers, so it won't damage the contacts, and it's a very good cloth to use for that. You can see all the dirt and oxidation I've been able to remove from this one cartridge, from the Super Nintendo, or this Mario 2 cartridge. So that is one way of doing it. Another way is to take the cartridge and actually open it up. This is the way I was trained as a computer technician to repair clean contacts on computers. Fit down inside and remove the screws out of the game. you can remove the screws. And once they're loose, that gives you access to the insides of the cartridge. Now you can see some of the connectors are kind of dirty. So now you can actually get access to the whole thing. But what I prefer, and what actually works very, very good, is to get just an ordinary pencil eraser and just real lightly erase the contacts. And you can actually see the difference as you go across them and clean the contacts. You can actually see the difference in where you've been and where you haven't. It may remove a small portion of the gold from the contacts, but that's all right if you don't brush real hard and go right through the gold to the copper. So just if you do it ever so slightly, ever so lightly, it does a very, very, very good job of cleaning the contacts. We'll lay that face down, put the cover back on. There are two little, in most of the cartridges, there's two little indexing pins that have to mate, and it's kind of tricky to get them back on. So if the screws are in it, so I dump the screws out, index it back together so it's back properly together, and then return the screws to where they were. Now don't over tighten the screw. If you over tighten the screws, you can actually strip out the plastic threads. They're very sensitive. What I'm going to show you now is how to repair the NES 002, the AC adapter. First thing you want to do on these is get your voltometer that you have, turn it on, and hopefully some of you have what they call continuity check. Continuity check is when the two leads are touching, it gives off an audible noise. You can hear it. Okay? First thing you want to do is put it on continuity check and check the primary windings of the AC adapter, and that's these two leads coming out. Touch them to the leads, and if it's opened, if you don't read anything and there's no beep, the AC adapter is probably not worth fixing. You may want to check to see if the cord is in good condition and the case is in good condition, and you may want to save that for pieces later on. But as far as repairing this adapter, if the primary winding is open, it's probably burned out and it's really difficult to fix. So what we're looking for here is we're looking for an AC adapter that has the primary windings closed so that when you touch this, it gives an audible beep. And then the next thing we want to look for is take this end, the barrel end, and put your leads across here, and it should be open. See, in this case, the secondary is closed, but the primary is open, and that means this is burned out, and so it's probably not worth fixing. So in a case where this is closed and this is open, then the chances are, as I will show you a little later on, the cable is broken. And so what we're going to do is there's two screws right here. We're going to take the cover off. We're going to effectively cut the wire approximately here and slide it up in here and effect repair. So we're going to do that. We're going to open this and I'll show you how to do that. First of all, we need a pair of needle nose pliers. Slots on either side of the head. It's a flat head. And so what I use is a pair of real fine, thin needle nose pliers. And they'll fit right down inside, and you can feel when you've broken the screw loose, and you can pull the screws out. Okay? I've loosened that one. Now I'm going to loosen this one. Okay? And just using a regular needle nose like that, you can pull the screws out. So what I'm going to do, I'm going to pause it now until I get the two screws out, and then once we get in, I'll show you what to do. Earlier. What you do is just loosen these two screws, and I've got them out far enough that now I can pull them out with the needle nose and set them aside. There's two screws, one up here and one down here. Then the front cover should just slide off. Okay. What I usually do is I take my wire clippers and I snip it about an inch or two right below where this bend has occurred. So I cut it off right there. Okay. Once I've cut that off, I want to reclaim this strain relief. So what I will do is, again, I take a single-edged razor blade and I cut very delicately along the side of it to pull the old cord out of it. Okay, and then you have the old strain relief that you can put back on. Okay. Okay, if the strain relief breaks, it's not a big deal. You really don't need it. So then what you need to do is meter and put the setting on ohms. Okay? And then when your setting is on ohms, check out the secondary winding of the transformer. So I'm going to put this on continuity check. Lay your meter across the secondary windings. And I have continuity here, which means the secondary of this transformer is good. Okay, now that I've cut this off, so I know the problem was probably in here somewhere. At this point is go ahead and clip off just below this shield, and I save that heat shrink shield insulator right there, and you go ahead and heat up one side of that, throw it away. Now this wire gets pretty hot, so what you have to do is hold it with something like needle nose so you don't burn your finger. And then heat up the solder joint as you carefully unsolder it and unwind it here. Okay, and discard those. So now you have the two wires coming out of the secondary of the transformer. We've now strip the wire back far enough that we can now, let me give it a little more here, just a little bit more. Okay. What I like to do is, as I mentioned earlier, save the heat shrink shield that was there. Okay. And go ahead and put it back over the wire that you've now taken off. You can tell just about how much you should strip by how long that insulation is. So strip it back, and then go ahead and slide it on. And now I'm going to tin the wires. Actually, what I'm going to do is put them on first, so I can get some good wrapping. So I wrap that side around, and using the soldering iron, solder it on, and now there's some of the at least. So then wrap that around, solder it back on, and to test it, you should have some kind of outlet to test it with. So what I do is just slide it back over here, plug it in, switch to AC volts, so you can see the AC volts here, and then get the end back up again, and you should have approximately 10 volts coming out. And so we've repaired it. Okay. Some people like to wrap electrical tape around there and put it back in, and some people just like to leave it the way it is. Go ahead and replace that, replace the cover where it's supposed to be with the strain relief there, and I didn't do a very good job here. If you make one good cut, it won't split like that, and you can pull it right out through the middle. And then simply replace your two screws and screw them back in with the needle nose until it's tight, and now you've repaired the AC adapter